And we have also discussed about the first moment business decision as part of exploratory data analysis. Most often than not, you'll be expected to explain your complete project when you attend the interviews. And you have to be very structured in explaining on what were the steps that you have followed in analyzing the data. The first step is first moment business decision, which is called as measures of central tendency. So the first measure is mean or average. The greatest disadvantage with mean is it is influenced by outliers. Then what is the next best measure if you have outliers? Median. Median is by definition the middlemost value of a given data set which is arranged of an arranged data set or sorted rather. Perfect. And median will not be influenced by outliers. And then we have mode. If you have data which is categorical in nature, that is when we resort to mode. Mode is the value which repeats itself maximum times, which appears maximum times is called as mode. If you have a single mode, by the way, mode can be applied even to numerical data. It can be applied to numerical as well as non-numerical data. And if you have a single mode, it is called as unimodal. If you have two modes, it's called as bimodal. If you have greater than two, it's called as multimodal. Presence of different modes explains you that there could be outliers in your data. Yeah, it explains about outliers in your data. And then we have second moment business decision. As part of this, second moment business decision is also called as measures of dispersion, in which you have variance. The disadvantage with variance is that your units get squared. For example, if you're dealing with, say, weights of people, and if weights of people are captured in pounds, when you apply variance, the units will become pounds square. If you're dealing with salaries of the people and if you calculate the variance, it will become dollar square or rupee square in that way. How do you fix this problem? We fix this problem by calculating the standard deviation. Here you get back the original units, and that's a plus part of standard deviation. There is yet another measure which is called as range. It is given using maximum value minus minimum value. And then we have third moment business decision, which is given using skewness, which explains about the presence of your long tail, whether the data are left skewed or right skewed. That kind of interesting insight can be drawn using skewness. And then you have fourth moment business decision. It will explain about whether the distribution is thinner or wider in comparison to your normal distribution basically. And it is called as kurtosis. Alright, this is exploratory data analysis for you. And then we have also discussed about what is population and what is a sample. In the real world, in the business scenario, you will never ever get access to the complete population. Hence, we apply a technique called as simple random sampling. So what we normally tend to do is, once we have a population, we try to get a sampling frame out of that. On this sampling frame, we apply simple random sampling, and from that comes your sample. Now the million-dollar question here is, how do you determine the sample size? Sample size is determined based on central limit theorem, as taking roughly 30. So approximately 30 data points is what is a good idea. And after taking 30 data points, you calculate skewness or kurtosis, and based on this you use this basic thumb rule, which is 10 times of skewness square or n greater than 10 times of modulus of kurtosis. Now, this would give you the approximate sample size. And when you work on population, you call the measures as population parameters, and population parameters are always represented using Greek letters. For example, if you have mean, it's mu, standard deviation is sigma, sigma square is variance, proportion is pi, so on and so forth. But when you work on sample and calculate the measures, you call it as sample statistics. And sample statistics has normal representation such as x bar, s, s square, proportion p, so on and so forth. All right. Post which we have also discussed about, as part of exploratory data analysis, the graphical representation. As part of graphical representations, we need to perform maybe bar plot, maybe dot plot, histogram. Histogram is primarily used to find out the distribution of the data, though you can use density or probability distribution plots. Then we have box plot, which is primarily used to identify outliers. Of course, these can be used in combination to get better benefits. Histogram and box plot, they both complement each other. And the various components of box plot are, you will have the least value, which is the minimum value. You'll have the maximum value. You'll have Q1 or quartile 1, which contains the 25% of data, lower 25. Q3, which is called as upper quartile. From minimum to Q3, you will have roughly 75% of data. And then you have the interquartile range, which is given using Q3 minus Q1, which contains middle 50% of the data. This explains about where does majority of your data reside in. And then we also have Q2, which is nothing but the median. Why median? Because box plot also helps you identify the outliers. And then you will have whiskers, lower whisker, upper whisker. Anything which falls beyond your lower and upper whisker would be called as outliers. All right. There are a lot of other graphical representations, but these will do the trick for us. And then we know for a fact that probability associated with a single value is always 0. Associated with a single value is always 0. So whenever you want to predict any value, say you want to predict the price of a used car, when you want to do that, you know for a fact that probability associated with a single value is always 0. And I'm speaking about this in terms of continuous data. When you have continuous data, then the probability associated with a single value is always 0. I'm not speaking about discrete. For discrete data probability, you'll have some probabilities even for single values. Hence, we cannot use a point estimate. Right? Point estimate for prediction is hence void. So what do I do? This is the reason why we need to calculate the confidence interval. And when you come up with this interval estimate, you should not come up with an interval estimate of your choice. There is always some confidence associated with the interval that you want to calculate. So let me put it in this way. So you need to come up with interval estimate basically. Right? And when you want to come up with interval estimate, you need some confidence. You cannot come up with any interval of your choice. So the confidence by default is set at 95%. Right? And then you need to calculate the confidence for this. If population standard deviation is known, then we resort to Z distribution to calculate the confidence interval. And the formula is X bar plus or minus Z value multiplied by sigma over square root of n. Okay, let me save this for all future purposes. Just give me one moment. Perfect. It is X bar plus or minus sigma Z into sigma over square root n. And here the Z value at 95% is 1.96. This will be standard, so it makes sense for us to remember these. Z at 90% would be 1.64 if I'm not mistaken, and the Z value at 99% is 2.57 something, 58. You can round it off to 58 also. So this is a Z value. If population standard deviation is not known, then we resort to T distribution. And here the formula is X bar plus or minus T value multiplied by S over square root of n. And when you want to calculate the T value, you have to look into confidence, which is 1 minus alpha, and you also need to look into degrees of freedom, which is n minus 1. So if you have these two values, you can calculate the T and substitute here. This is how you counter the problem of probability associated with a single value being 0.